Good morning, learners and viewers. Welcome to the session for Maintenance Management MMPO007. We will be continuing with Unit 13, that is Total Productive Maintenance. Today, we will start with Autonomous Maintenance. Autonomous maintenance is the carrying out of maintenance activities by machine operators in close coordination with maintenance department. Autonomous maintenance by operator is one of the primary feature of total productive maintenance and is a key point in its development. In autonomous maintenance, the operators learns to carry out the housekeeping and maintain basic equipment conditions, that is lubrication, adjustments, minor repairs, etc., were required during the production process. GIPM describes the critical operator autonomous maintenance skills to be ability to discover abnormalities, ability to correct abnormalities and restore equipment functioning, ability to set optimum equipment conditions, and ability to maintain optimal conditions. The Japanese Institute of Plant Maintenance has developed a seven-step procedure to evolve autonomous maintenance. These steps are: step one, that is initial cleanup, thorough cleaning of dust and dirt on the equipment, lubrication, machine part adjustment, and discovery and repair of minor defects constitute the first step. Second step is to measure against sources of outbreaks. As the second step, the operator prevents the cause of dust and dirt and reduce the time required for cleaning and lubricating. Step three is formulation of clean up and lubrication standards. The operator sets a standard for cleaning, lubricating, and parts adjusting. The standard should be achievable, and a specific time period for carrying out the above also have to be set. Step 4 is overall checkup. In this step, the operator is required to be trained on checkup skills in accordance with inspection manuals, findings, and correcting minor defects through overall checkups. Step 5 is autonomous checkup. It is a formulation and implementation of autonomous checklists. Step 6 is orderliness and tidiness. These two aspects of workplace management are taught and practiced in this step. Step 7 is all out autonomous management. Engaging in continuous improvement activities on the basis of observations of failures or malfunctioning from the last step of autonomous maintenance development program. Then comes your small group activities. Japanese industries are well known for their small group activities. The first of the many small group activities in Japan came into being when the quality circles, what we call it as QCs, were introduced by Nippon Denso in 1962. 3 years later, 1965, the American concept of zero defect, that is ZD, was given the form of a group activity through ZD groups in line with QC circles. The other famous group activities in Japan is known as JK, that is Jisnu Kanri or autonomous management, which is widely practiced in Japanese steel industry. Small group activity is the unique feature of total productive maintenance and is aimed at being participated by everybody in the organization. The overall equipment effectiveness, that is OEE, needs to be calculated for an 8-hour shift. A filing plant runs for 7 hours during an 8-hour shift. The plant produces 5 bottles in an hour. Due to short downtime, the plant could only produce 2,000 bottles during the 7 hours. And out of these, 100 bottles does not have the desired fill volume. That is, they are included in rejections. Now we have to calculate the availability. Since machinery is in operation for 420 minutes, 60 minutes are lost due to technical issues. The runtime is 7 hours, that is 420 minutes. Downtime is 1 hour, that is 60 minutes. The availability factor is runtime into runtime plus downtime. So we have to calculate the availability. That is 420 minutes divided by 480 minutes, which comes out to be 0.875. That means the machinery has an availability of 87.5%, and 12.5% of the time available is lost due to the disturbances. Then comes your performance. A machinery is in operation for 420 minutes. The planned speed is 5 bottles per minute. Actual performance was 2,000 bottles. The target performance will be 420 into 5. That comes out with 2,100 bottles. Performance factor will be actual performance to target performance. That comes out to be 2,000 divided by 2,100, which is equal to 0.952. That means we can say that machinery has a performance factor of 95.2%. Then comes your quality. The machinery produced 2,000 bottles. Out of those, 100 bottles did not have the desired quality. That means they were rejected. The number of bottles produced, 2,000. Rejection is 100 bottles. Quality factor comes out to be, is calculated as number of parts produced minus number of rejects divided by total number of parts produced, which is equal to 1,900 divided by 2,000, which comes out to be 0.95. Or we can say that quality factor is 95%. Now we have to calculate OEE. OEE is the product of availability factor and performance factor and quality factor. So the formula is OEE is equal to availability factor into performance factor into quality factor. We have all these values. This comes out to be 0.791. That means we can say that machinery has an equipment effectiveness of 79.1%. Now we have to calculate the OEE over an 8-hour shift that had a total of 5 planned breakdowns that amount to 50 minutes. 10 minutes of unplanned downtime due to a tooling failure. Ideal rate of machine to run this part was determined to be 400 pieces per minute. 150,000 pieces produced over the 8 hours shift. And 25,000 pieces was scrapped due to be out of specification, that is rejection. Now we are aware of how the calculation is done. So availability will be 420 divided by 430, which comes out to be 97.67%. The performance is 1 lakh 50,000 divided by 1 lakh 68,000, which comes out to be 89.29%. Then comes your quality, that is 1 lakh 25,000 divided by 1 lakh 50,000, which comes out to be 83.33. Now, we are being asked to calculate the OEE, that will be the product of these three factors, that is availability, performance, and quality. After multiplication, we get 72.7%. Now we move to unit 14, that is maintenance audit. We are all aware of it. Audit is a necessary part, whether it is related to finance or it is related to machinery. Audit is necessary and compulsory. Certain functions of a company are compulsory, audited by either mandatory provisions or as required by the certifying agency. For example, finance statements like annual accounts must be compulsorily audited by a certified practicing auditor. Similarly, the recent Conservation Act, passed by the Parliament, makes energy audits compulsory for highly energy consuming industries. For obtaining certification in the ISO 9000 series, that is 14,000 systems, once again, auditing is prescribed by the standards. Factory Act specifies mandatory safety audit for highly hazardous factories. All these audits are enacted by law to safeguard the rights of different types of stakeholders of an organization, like shareholders, employees, customers, the public, etc. Now, what are the different types of audit? There are various types of audit that are possible to be carried out in an organization. It would be useful to understand these terminologies so that one is able to understand and appreciate their purpose and requirements for different situations. We will start with statutory audit. This is the audit required by law, enacted by the parliament or legislature of the country. Sometimes our statutory or semi-statutory organizations like International Labour Organization ILO, International Standard Organization ISO, etc. also make specific provision for such statutory audits. Internal audit. It is an audit taken by the internal department or personnel of the company. Normally, one department auditing the functions of other department. External audit, as the name suggests, is the audit conducted by an external agency, that is neutral third party, either due to wish of the company management to identify problems for improvement or mandated by enforcing agencies like the government. Then comes your preliminary audit. It is normally conducted for a brief period of time to identify major thrust problems area in a function. The problems so identified may be subjected to detailed examination and problem solving at a later stage. On the other hand, a detailed audit is carried out to study the complete features and requirements of a specific function. Management audit. It is an audit carried out to check and identify the suitableness of system and procedures of a management function. The audit carried out for ISO 9000 certification is an example of such an audit. Then comes your technical audit. It is a process of study of a technical component of a plant with or without experimentation and instrument monitoring to identify improvements in both the hardware and software aspects. All these types of audits have some amount of overlapping in their purposes and applicability. All these types of audits have similar methodologies also. What is the importance of maintenance audit? Why it is required? Why it is needed? Maintenance audit, when properly and regularly conducted, will have the following benefits. It helps in confirming the function is performing towards the objectives that are set forth for it. Secondly, to compare the performance indices of the function with that of the targets as well as the similar benchmarks for the industry sector or with the world class best benchmarks to identify weak areas for performance improvement and implementation strategies thereof to be carried out or to be certified towards proper system functioning from the auditing agency, which may be the requirement of a statutory and standards agency, and to apply and obtain popular awards like Total Productive Maintenance Award, etc. What is the methodology of maintenance audit? The steps in maintenance audit are: first one is initial orientation. The auditing team has an initial meeting with the representatives of the company's senior management and the regulating agencies, if any. In this meeting, the goals, scope, and coverage, information requirement, schedules, and the techniques of the audit to be employed are presented in a summarized form. Second one is preliminary preparation. During this step, the auditor's team, the management and technical information obtained in the initial orientation and prepares a plan for addressing the major concerns expressed by the company management or the regulator. Next one is preliminary questionnaire survey. The auditor prepares a detailed questionnaire on the various issues of concern in maintenance management and circulate in advance to the company's management personnel. The questionnaire contains a systematic identification of elements and series of questions to collect information about the same. Then comes your plant visits. The auditing team undertakes a field visit to the plant to collect maintenance audit field information. During this visit, interviews are held with senior managers, supervisors, and technicians, etc., to obtain a first hand feeling of the management factors and concerns and feelings. Then comes data analysis. During this step of the audit, the study team reviews, digests, summarizes, and analyzes of data and information gathered. Profile of maintenance management performance are developed and compared to the company's past performance and to the performance of the industry and to similar companies. Then comes your seasoned judgment. Both in tempering quantitative evaluation and in measuring less tangible performance factors must be used. Development of conclusions and recommendations. Based on the above evaluations, the auditing team develops conclusions about the efficiency and effectiveness of the maintenance management system. The factors that were observed to be examples of good management practices are listed with supporting evidence and data, and thus conclusions to the strength of the systems are identified. After all these processes are performed and completed, then comes the report submission part. The audit team prepares a comprehensive report indicating the scope of the audit, methodology adopted, information gathered, analysis performed, and recommendations arrived at a result of the audit. The report submission is often accompanied by a direct presentation to the management or regulatory agency when the action plans for the implementation of the suggestions and the requirements of the involvement of the auditors further can be discussed. Study of key result areas. Maintenance management audit must focus on both the results achieved and processes used to have holistic idea of the system efficiency and effectiveness. The major maintenance benchmarks which need to be studied in the audit are maintenance cost. Some of the major cost factors or ratios that need to be analyzed are total maintenance cost, maintenance cost to budgets, maintenance cost for unit output, maintenance cost per sales, maintenance cost per asset value, and contractor cost ratio to the total maintenance cost. There are various factors for the analysis. We will see how they work. Maintenance materials management performance. The factors ratio related to the maintenance material management performance are material consumption value to total maintenance cost value, inventory turnover, number of stockouts, performance of plant and equipment maintenance. The ratio that represents the plant and equipment maintenance performance are downtime ratio, spare part consumable consumption ratio, redundancy in equipment, design life to replacement life ratios, etc. Then comes your maintenance organization performance. The organization performance of maintenance management is measured by the ratio of maintenance manpower to asset value, planned maintenance work to unplanned maintenance work, and backlog by crafts, etc. IT system usage for maintenance. The maintenance function has invariably taken the assistance of information technology, which is known as computerized maintenance management system, what we call it as CMMS. An audit will look for ideal features in the CMMS system, the extent of use of the system, and the utilization of its fullest capabilities. Now we move to Unit 15, that is Maintenance 4.0. The foundation of Industry 4.0 is the internet connectivity of machines. Here, every step of the industrial production process interacts with each other to adjust as per the requirements and always function at its best. This revolution uses various technologies like artificial intelligence, AI, Internet of Things, IoT, virtual reality, VR, sensors, robotics, big data, and others, which is helpful for maintenance, company commonly known as Maintenance 4.0. This new digital era has several benefits, including tracking equipment investment and returns, break down communication barriers, and projecting the organizations into the market. Big data, for instance, is a powerful ally for equipment reliability focused maintenance. The usable life of equipment The danger of breakdown and the corresponding effects on the system may all be determined with higher accuracy using big data technologies and artificial intelligence. In maintenance 4.0 environment, we can swiftly identify faults using the sensors, the Industrial Internet of Things, that is IIoT, big data, artificial intelligence, and other intelligent technologies. Maintenance 4.0 solutions may assist businesses in managing their equipment and determining when machines need maintenance, repair, or replacement before any disruption to production occurs. This maintenance revolution is quite helpful for predictive maintenance, which is the best industrial maintenance. With the aid of computer system, we may anticipate problems and choose the best time to replace or fix things before a breakdown happens. When with IoT sensors, operators may get data from tools, cars, and other equipments to more accurately forecast how and when something could fail. Operators can calculate when and how different parts might need maintenance and repair by comparing and combining data from environmental and operational sensors with previous maintenance records. Maintenance 4.0. Now we will see. Actually, this maintenance 4.0 is the fourth industrial revolution or industry 4.0 is a startling automation and digital connectivity trend that has swept the globe. It encompasses or it includes big data, wireless sensors, cloud computing, artificial intelligence, machine learning, and the Internet of Things. Industry 4.0 main focus is on using technology to link equipments, operators, and processes, which is helpful for maintenance. Advanced sensors, robots, and embedded softwares are features of smart factories that gather and analyze data to help in decision making. Typically, when it is required to get an information on the condition of the machinery, we consult with specialists with expertise in this field. Machines may carry out these duties in maintenance 4.0 because of the development of new linked technologies, which increases machine components usable life and prevent malfunctions. Maintenance 4.0 makes extensive use of complex systems for both people and technology. These systems easily fall apart without bringing us closer to our maintenance objectives. A well designed preventive maintenance programs, practices, procedures, and equipment boosts like likelihood of the maintenance 4.0 transition going smoothly. It is simpler to fully use the system of maintenance 4.0 when there is a wealth of high quality data. What are the requirements for maintenance 4.0? The major requirement of maintenance 4.0 are controls over maintenance management, which reduces the repair cost and total machine failures. Secondly, it undergoes adequate maintenance and inspections, which helps to spot problems before they arise. Thirdly, It will be maintained with the requisite components, cleaned, greased, and anything else needed to keep the equipment functions well. A machine that receives a regular maintenance will work better and live longer. That only gets repaired when it breaks down. Maintenance managers can plan their budgets ahead of time, make use of allocations, and guarantee that their equipment is well maintained. Predictive maintenance. Predictive maintenance employs IoT sensors and predictive analytics software to check the equipment state in real time and find indications of abnormalities or degradation that might result in failures as predicted by the software. Predictive maintenance is used in manufacturing facilities to maintain optimum production by identifying failure modes, the specifics of what is falling, and the anticipated failure date. This prevents equipment shutdown by allowing maintenance team to prepare personnel and inventory for critical repair operations well before the expected failure. Regarding preventive maintenance, predictive maintenance uses sophisticated data analytics and predictive modeling to spot probable equipment faults before they happen. Predictive maintenance uses real time equipment monitoring and analysis to identify potential faults and take appropriate steps to minimize downtime. Mobile applications for predictive maintenance are being improved by integrating cutting edge technologies like artificial intelligence and machine language. These technologies significantly lower the risk of equipment failure by enabling mobile applications to learn about and adjust to particular equipment circumstances. Predictive maintenance will continue to develop due to the combination of maintenance 4.0 and mobile applications, IoT, that is Internet of Things. Device use will increase and machine language algorithms will get better at spotting equipment's breakdown. Predictive maintenance is now even more accessible and effective because of the growing popularity of mobile applications, which also lowers maintenance cost and increases safety while boosting equipment uptime. The future of predictive maintenance becomes even more bright as companies continue to use cutting edge technology. Predictive maintenance may also save maintenance costs while increasing overall equipment efficiency. Predictive maintenance through maintenance 4.0 technologies. Predictive maintenance is a strategy that uses data analysis tools and produces to find irregularities in our business's process and potential flaws in our machinery and workflows so we can correct them before they break down. Predictive maintenance leverages historical and current data from many areas of our business to identify issues before they arise. Vibration analysis, oil analysis, thermal imaging, and equipment monitoring are examples of predictive maintenance applications. Machine language techniques are used to analyze data to find trends and forecast when necessary maintenance is necessary. Large data sets may be collected using IoT devices to monitor equipment continuously. Equipment failure predictions may now be made with greater accuracy using machine language techniques. The maintenance process is evolving as a result of Industry 4.0, and maintenance specialists may work more successfully and efficiently by integrating smart devices, powerful analytics, and mobile applications for predictive maintenance. Using IoT for predictive maintenance has several advantages. Equipment downtime may be reduced, and production schedules can be kept by anticipating maintenance needs. Mobile app usage for predictive maintenance creates additional security difficulties. Mobile devices are susceptible to cyber attacks, and confidential information about the efficiency of the equipment may be jeopardized. Security precautions, including encryption and safe data storage, must be carefully considered when employing mobile applications for predictive maintenance. Major capabilities of Maintenance 4.0. The Industrial Internet of Things, that is IIoT, enables condition monitoring using real time data in predictive maintenance operations. In supports dynamic operational efficiency increases, identifies possible problems, and helps firms fix them before serious equipment malfunctions, making it a crucial component of Maintenance 4.0 revolution. In Maintenance 4.0, predictive maintenance is heavily reliant on IoT, employing machine language algorithms to anticipate failure and dangers and forecasts when industrial equipment is most likely to break. Organizations may store and analyze terabytes of equipment data using an IoT based solution. Artificial intelligence and sensor data are integrated into predictive maintenance systems to find the causes of outages. It aids utility providers in choosing the most effective repair schedule to avoid power outages. Advanced maintenance. The concept of Maintenance 4.0 is useful for preventive maintenance, which provides advanced maintenance signals. It guards against equipment and assets breakdown. When doing this sort of maintenance, the equipment is checked even if there is no visible sign of deterioration. Data analysis of assets, machinery, or equipment is aided by IoT enablement. Sensors and other tools gather information, provide dashboard reports on the condition of the equipment, and forecast problems and dangers that need quick action to prevent outages and avoidable downtime. It enhances our company's uptime, effectiveness, customer satisfaction, supply chain production results, and many more. Real time monitoring of the state performance and health of the industrial equipment is facilitated by Maintenance 4.0. To save costs and unplanned failure, it schedules the maintenance of the manufacturing equipment around the production schedule. Condition monitoring of industrial assets. The effectiveness of industrial asset is assessed using condition monitoring technologies via maintenance 4.0. A condition monitoring device known as an IIoT sensor may continuously record various data including temperature, vibrations, and conductivity. It is crucial in this situation because it can translate and analyze recorded data to determine how long it will take to complete maintenance tasks that will stop failures from occurring early. With maintenance 4.0 technicians may do repair before a piece of industrial equipment breakdown, and personnel are nowhere to be found when it does. The approach ensures fewer emergencies so that engineers and maintenance managers may focus more on productivity while still doing their usual tasks. It notifies the progress of the work. Maintenance managers may notify end users of the work's progress using work order management. Monitoring the performance of each production asset separately is made easier with the use of work order management. Reduced downtime, fewer production gaps, and cost savings are just a few benefits of IIoT. That is why investing in IIoT for predictive maintenance makes sense when a company uses a lot of industrial equipment. Maintenance 4.0 ensures that the most data is gathered, processed, and then used to forecast certain manual or automated results. Large amounts of historical data may be analyzed using complex algorithms by predictive analytics system, which can also spot issues that are not visible by hand. Then comes your maintenance planning. Maintenance 4.0 is based on analyzing data obtained from sensors and other technologies. The capacity to gather and analyze the vast amount of historical data that manufacturers consistently create is usable information that enables demand, production, and maintenance planning. Gaining more productivity and efficiency while ensuring top-notch product quality benefits is essential in today's fast-moving era of productivity and business. Automation, robots, machine language, artificial intelligence, and others makes a dynamic and highly productive corporate environment possible. It also saves precious resources, and industry needs maintenance to keep things running smoothly, save time, and save precious resources. Maintenance 4.0 can take business to a whole new level. It will benefit the companies immediately, but it will also provide us with an advantage over rivals. Maintenance 4.0 analysts often offer positive and aggressive predictions. Maintenance 4.0 is the practice of routinely maintaining machinery systems or equipments to prevent or minimize breakdowns, or at very least lower their frequency. Evaluating the difficulties. Assessing our difficulties is the first step in effectively planning and integrating maintenance 4.0 into any company. Processes for developing mobile apps are being more automated and standardized using Industry 4.0 and cloud computing. This has improved productivity, speed up development cycles, and increased mistakes and defects. In the industrial sector, Maintenance 4.0 has aided product makers in keeping an eye on the temperature of their equipment and preventing overheating, which might result in malfunctions and unscheduled downtime. Create continuous improvement. It is a continuous ongoing process. So how does it work? Maintenance 4.0 is a significant shift that covers a wide range of topics. Besides doing a fantastic job for organizing and educating the maintenance team, we also need to prepare for the adjustments that new systems and procedures will bring about. A maintenance 4.0 capability may effectively integrate the benefits of big data and IoT to forecast the life of the equipment, the likelihood of failure or downtime, and the corresponding impact. These technologies allow more easily controlled or monitored activities, simplifying maintenance. It seeks to improve intelligence while also making maintenance simpler. With Maintenance 4.0, we can use cutting edge ideas like artificial intelligence and automated troubleshooting to increase our operating efficiency, enhanced productivity and efficiency. Mobile apps may operate more collaboratively and streamlined, increasing efficiency and productivity by using the agility of Maintenance 4.0 and the scalability of cloud computing. Project management and collaboration platforms, among others, cloud based solutions and enhanced deep communication and transparency lowers the possibility of misconception and misinterpretation. It is simple to envision a future in which increasingly delicate equipments can transmit incredibly detailed information about operational performance and environmental conditions and the integrity of a specific assets, primarily structural material. Preventing future problems with the help of Maintenance 4.0. Facilities can forecast when equipment breakdown may happen and take preventive measures using Maintenance 4.0 technologies. It aims to reduce time spent on unexpected maintenance while maintaining a low maintenance frequency. This includes less downtime, enhanced safety, higher output, and other advantages. Manufacturers gradually find themselves merging old systems with cutting edge technologies. To meet the demands of their client, manufacturers must create an enormous amount of goods. Therefore, to accelerate the manufacturing process, producers uses machines. Processes are streamlined by the use of computer integrated production in smart manufacturing, cost management. For many businesses, the bottom line takes precedence above all the considerations, regardless of how technology develops. Inventory management is one area where the transition of maintenance 4.0 may help maintenance team save money. With the help of new technology, facilities may streamline the ordering process and reduce the resources needed to maintain a complete inventory. Increased dependability and lower cost results from a smaller, more effective inventory system. The creation of mobile apps have been revolutionized by cloud computing. Cloud computing offers flexibility, scalability, cost effectiveness, and security for creating mobile apps. The capability to grow fast is one of the most important advantage of cloud computing for mobile app development. Useful for routine maintenance. Equipment that receives routine maintenance will perform better than equipment that gets only repaired when anything goes. It might harm the equipment long term, impairing its performance and making it ineffective. Regular maintenance, lubrication, cleaning, and inspections are performed on the equipment as a part of Maintenance 4.0 to improve efficiency and spot any issues that may be later apparent. Equipment malfunctions would occur more often without routine maintenance and need many more repairs. Usually, emergency repairs are more costly, and if extra parts are required, those prices are further increased. Improved flexibility. Mobile app developers can now construct extremely scalable, versatile applications and handle significant traffic and data volumes using Industry 4.0 and cloud computing. In the quick moving app market, cloud resources allow app developers to swiftly adjust to shifting client and market expectations. Maintenance 4.0 technologies increases flexibility in maintenance. Maintenance 4.0 and cloud computing integration in mobile app development is a subject that is constantly changing, with new possibilities and trends appearing all the time. To ensure that equipment receives prompt service, maintenance, and repairs, and that uptime is maintained to a minimum. Maintenance management, particularly maintenance 4.0, is helpful. It saves businesses money. The contemporary manufacturing process includes maintenance 4.0 as a crucial revolution. It may be used in manufacturing, aerospace, automotive, and energy sectors by minimizing downtime and eliminating equipment failures. Maintenance 4.0 may save businesses money. It can also help businesses provide better customer service by enabling them to prepare for equipment failures. Artificial intelligence is being used to transform the way that machines gather and interpret data completely. If certain sectors continues to use outdated technology, they will go through the most significant shift if they have ever gone through. Nowadays, businesses use cutting edge technologies that enables communication between people and robots. These solutions assist companies in improving choices, applications, and customer service. Then comes your factory management. The most cutting edge and effective maintenance management strategies are found in Maintenance 4.0 systems. It brings about a revolution in factory management that is readily connected to IoT, cloud computing, and cognitive computing, all of which are necessary for plants to become intelligent. Information might be easily exchanged across the departments, sensor tools, and systems. Maintenance 4.0 solution may provide a trustworthy evaluation with the use of acquired data to help administrators decide strategies for the efficient operation of the facilities. With all the advantages of cloud computing technology for revolutionized the creation of mobile apps and is still a crucial engine for digital innovation. How to overcome various difficulties. Companies may overcome various difficulties and develop mobile applications supporting their corporate objectives using best practices, including collaboration, agile processes, and cloud native architectures. The creation of mobile apps will have even more intriguing opportunities in the future using artificial intelligence, computing, and blockchain technology trends. In order to create optimized maintenance plans, this integrates maintenance data about the specific assets with knowledge about business operations. Planning for remote maintenance procedures may result for extracting maintenance 4.0 information from assets. Technicians are shown via augmented reality virtualization how to maintain certain assets. Technicians and field engineers are given relevant maintenance instructions for the equipment over digital representation of the assets. Maintains track of all the information. Maintenance 4.0 technologies keep track of all the information about the assets that are held in it, including the dates each purchase received maintenance. Based on how the asset is used, we may plan maintenance. We may plan maintenance on daily, weekly, or monthly schedule if the asset is utilized over a number of hours. Additionally, the maintenance staff and management may create a reminder for maintenance using this program, eliminating the need for them to recall manually. The creation of several value added functions that enhance maintenance procedures and assist professionals in making the best choices possible regarding asset inspections, equipments, repair, and field service engineering operations is made possible by extracting predictive asset insights. Foresee equipment breakdown. Engineers use a predictive maintenance technique to foresee when equipment breakdown can occur and then carry out repairs to keep the machine running. This ensures that a piece of machinery that needs repair is only turned off before it is about to fail, preserving assets for as long as feasible. Regular asset status checks are done by conditioning monitoring used in Maintenance 4.0. In today's engineering world, monitoring the support is crucial to reduce failures and downtime of essential equipment since it enables corrective action to be done and production to be safeguarded. With thorough, precise information, advanced technology can perform its function using Industry 4 technologies to their fullest capacity in similar when there is access to high quality data. Therefore, the moment has come to begin compiling that intelligence inventory. Accident prevention. The maintenance 4 approach has advantages over such as resource optimization, accident prevention, and improved operation performance. Using scheduled downtime, maintenance 4 has also improved asset management. Maintenance downtime may be arranged in advance using live data feeds from linked assets that assists providers in determining when train carriage is likely to malfunction. This enables operators to manage maintenance downtime around timetables to minimize its impact on services while in part maintaining rolling stock in the best possible operating state. With the advent of Industry 4.0, real time analysts, artificial intelligence, and machine learning, it is now possible to automate asset maintenance, speed up business processes, and save expenses. With this, we will be concluding this session.